Hi, everyone. Welcome to Unbounded by Dell Technologies. Thank you so much for joining in. I think we'll just give the other participants a couple of minutes to join in, and then we're going to start very shortly. So just hold on tight. Thank you. I think the attendees are still joining in, so we have done a short announcement on Slack as well. So we will just give it a couple of more minutes, and we're going to start post that. All right. I think in the interest of time, we'll quickly start and let the other attendees join in as we go ahead. For all of you who would be missing out today's session, just a quick info. We also have the streaming live on Zoom, as well as we'll have the recording posted in for you later. So in case you guys are missing it out, you can definitely catch up on the recording. But I would suggest that all of you attendees who are out there, you can just quickly ping your friend, teammates, to join in as soon as possible. I think it will be great, and we can have a lovely session. So with that said, let me quickly begin. First of all, let me start by saying, extending a very, very warm welcome to all the participants who have joined in. I hope you are staying safe and doing good. So thank you so much for joining Unbounded by Dell Technologies and the opening ceremony. Again, a very warm welcome and a big thanks to the panelists who have taken out time today, including the judges, the mentors, the organizing team, to be a part of this opening ceremony. So a very, very warm welcome to all of you out there. All right. So to begin the proceedings, I'll quickly share the deck that we have for you, and we can start. I hope my screen is visible. If any of the panelists can quickly.
Yes.
Thank you so much. All right. Welcome to Unbounded once again, Unbounded by Dell Technologies. Now, what is Unbounded by Dell Technologies? I think you've heard a lot about this, over the past month or so. You've joined Slack, you've seen it on our website, but just giving you an overview of what we want, what is there in store for you in the next 3 days. It's basically 3 days of virtual hackathon, which aims to bring developers like you, designers like you, and entrepreneurs like you to solve challenges using Pravega, an open source storage system. So we are so glad that you have joined us today, and we are just looking for 3 days of fun hacking, fun events, having the connect with the judges and mentors, and having some speakers on board with us with some really cool topics that I'm sure you would love to hear on. What we have in store for you in terms of prizes, I think we have a lot of prizes in store for you. And once we go ahead, our Dell team will give a detailed feedback on what prizes are there in store for you. So with that said, let me just quickly introduce myself. I'm Astha. I am basically the global account manager at Angel Hack, and I'll be your host for the evening. Along with me, I have my colleagues, Trisha, she's from our marketing team. We have Valerie, she's from the account management team. And we have Harish, who's the community manager. And they would all be helping us with the presentation today. And if you're thinking I have still not introduced my Dell colleagues, please just hold on. I would be doing that very shortly. Okay, hackathon partners. This hackathon is powered by Angel Hack and sponsored by Dell Technologies. What is the webinar agenda? So what do we have in store for you today? We will do a quick introduction to your judges. We would then have the keynote speakers take over and take you through what is Pravega and the different topics we have in store for you today. We would then go through the quickly through the rules, schedule, and then we would introduce you to the mentors and the organizing team of Dell. And then we have the challenges, prizes, the winning how do we do the winning announcement, and all the operational and technical details for you. With that said, let's quickly begin with the judges' introduction. So for our judges for Unbounded by Dell, we have a very esteemed panel. Let me start by introducing Mr. Flavio. He's a senior distinguished engineer at Dell Technologies. We have Mr. Srikanth. He's the Vice President, Objects, Streams, and Analytics at Dell Technologies. We have Mr. Ashish. He is the Director, Software Engineering, Streaming Data Platforms at Dell Technologies. We have Mr. Russ. He's the Senior Product Manager at Dell, ECM at Dell Technologies. And finally, we have Mr. Arnold. He's the Global Product Lead, One Cloud Data and AI at ADOS. So to begin the proceedings, I would just invite Srikanth, Mr. Srikanth, to say a few words. So I'll hand over the platform to you.
Hey, good morning, everyone, or good afternoon, good evening, depending upon wherever you are. I really appreciate you joining and taking part in this hackathon connected by Angel Hack and Dell Technologies. One thing I want to tell is the spirit of Pravega. What has happened in the open source is either companies get popular with one open source product and form a company and then start making a premium version, which is not open sourced, or there are some other companies, particularly in the cloud, which have just taken open source and made a service out of it. But the real true spirit of open source is when we all work together in building a product, and then everyone gets to use it to form different products. And that's the spirit of Pravega, and that's the way we formed Pravega right from the starting. In fact, the product at Dell Technologies, we all work on Pravega at the same time we work on our products also. But whatever you see in the open source is exactly what we use in our products. And that, I think, is the real spirit of open source. We want to imbibe it. We want to enjoy it. We want everyone to enjoy that, and everyone, the community, to flourish as in the process. And that's why we started Pravega with a different notion that we are never going to make a company out of it, or we're not going to make a premium product out of it. Whatever you see in the open source, whatever contribution anyone does, it just comes out like that, including us. Our contribution to Pravega will always be open source. It's a different thing. We'll form different products around it, but we'll use the exact same bits that are available in open source. And that's the spirit of open source that we want to really encourage in the community, right? And second thing is, we have seen a lot of messaging products come out, and people always treated them as temporary places where you store stuff and then you move into different places. But for the first time, we want to give messaging a kind of respect of an enterprise-grade product that is not for a temporary message buffer, but the real place where you store products, store information, whether it's events, whether it's data from applications, or even big things like video files, big files like videos and other things. One place where you can store an event-based processing is possible from it, both for near real-time processing and also for batch processing. And that kind of a thinking never existed in the messaging systems before. They're always meant to be temporary message buffers, right? So we want to completely challenge that and provide stream as a fundamental data storage primitive. So these are the two primary reasons why we started Pravega a couple of years back. And right from the starting, we did it in open source, and we had Apache 2.0 license, which is the most liberal license out available, and we'll continue to keep it that way. So that spirit, I really appreciate all of you joining it to kind of leverage this product and kind of show your creativity in terms of different applications or products that you're going to build over this hackathon. And welcome again. Thank you.
Thank you so much, Srikanth. That was really insightful. Thanks a lot for doing this. Moving on, I think we have the flavors and spirits of Pravega, which would be taken by Mr. Flavio. So I'll hand over the platform for him to share the slides and talk about it. So over to you, Flavio.
Thank you, Asta. Okay. Can you see my screen?
Yes, we can.
Okay, it's displaying well. All right, so thanks, Srikanth, for the introduction, the insightful words. This presentation is actually all about that. I want to also take a few seconds just to thank everyone for joining this hackathon. My experiences with hackathon have always been a lot of fun, and so I really ask all of you to have fun in the process. Not only learn but put effort into coding, but try to enjoy the effort, push the boundaries of Pravega, talk to us, ask questions. So do all that as part of these 2 days that you have of this event. And so my goal here is to expand on what Srikanth said and talk about the spirit of Pravega, talk about some of the important concepts, why we're doing what we're doing, why Pravega is out there, the kind of capabilities it offers, give you an overview of that, and while comparing even with other systems that you have out there. Srikanth mentioned messaging systems. I'll talk a bit about those as well. As part of to start the conversation and tell you a bit of about some of these concepts, I want to start by with a little story, which I'm going to call a startup tale. All right. So the idea is the following: meet our entrepreneur N. So N has the following idea. So N thinks that people who order pizza regularly, so they care, of course, about the quality of the pizza. It needs to be good pizza. They want good price. They want it delivered fast, but they don't necessarily care about where it's coming from, as long as it meets all those goals. And so her idea is to build a pizza service. Pizza service, it's an app. It has an app. It has a sharing platform where different restaurants come and register to serve. They must pass some certification, of course, to guarantee the quality that we are talking about. Users sign up to order through the app, and that's essentially what the service is about. So the flow when you want to order pizza is you go, you select your type and toppings, and the first available shop nearby will pick the order and will have it delivered to you. And based on volume, she would try to have discounted prices. And she's going to call this service Feeling Lucky Pizza, all right, FLP. In fact, the FLP has a distributed systems short reference in there. I don't know how many of you actually got the reference. I'm just curious to know how many distributed systems geeks are out there. So if you got the reference, ping me on Slack. I'll be curious to know. So FLP. FLP on a regular day, you have groups of people sending their orders, and that forms a stream of pizza orders. All right, forms a stream of pizza orders. So when they submit an order, they receive an acknowledgement that has been received. At some point at the processing of the stream, the service matches the order to a restaurant. The restaurant will prepare the pizza and deliver it. So on a regular day, this is what happens. Now, we focus a lot on fulfilling the order, right? So the tail of the stream. But if you think about it, even though that is very important, that's not the only important part of the stream. So N might want to use the historical data of orders to perform some analysis and derive patterns out of all that data. So again, it's not only about looking at the tail of the stream. For some tasks like analysis, she might want to go back in the past and look at all orders, may even help the restaurants downstream to decide when to order more ingredients, or when some types of pizza are more ordered, or even when pizzas are ordered throughout the day and seasons, etc. And so the ability of ingesting and preserving both tail and historical data, they're very relevant for this toy service that we are talking about. Now, there are other things, of course, that N needs to worry about. So customer orders and no pizza ever arrives. So customer is going to get upset. It's going to call N and we're going to say a bunch of things, right? But there could be the problem that the customer gets duplicated orders. So instead of getting one order or one pizza that the customer ordered, customer gets 8 pizzas and is charged accordingly. So N feels like saying, well, it's the TCP connection that keeps dropping, fix your network. But she can't really say that. Customer, of course, wouldn't understand it. So the best she can say is, I'm very sorry. But the bottom line is orders must be received and processed once and only once. So there must be a guarantee in that stream of pizza orders that the event will be received and processed and be fulfilled exactly once. One more thing is that in your part of the world, maybe there are different events that trigger a surge of pizza orders or even other kind of orders. But where I am, so soccer nights can trigger that. So we have a soccer night, a lot of people ordering pizza. So all of a sudden, your workload doubles, right? So during on one particular day, during some part of the day, you get a spike on the workload. So the ability of adapting to such workload variations is also very, very critical, so that you don't drop, you don't duplicate, you don't do funny things that your customers do not expect. So this ability of scaling is also very important for this toy service. And so Pravega is about all that. Pravega provides the ability of ingesting, storing, and bounded data streams. One of the requirements that we have set for that service, it provides exactly one semantics. It's able to scale streams according to variations of the workload, and a lot more. It provides features that enable state replication. It enables you to store key value tables, manage schemas, connect to other systems to form data pipelines. So all those, again, are part of Pravega. Pravega is also focuses on being cloud native. And there are 2 aspects that are relevant when I say cloud native. One is to build on horizontally scalable cloud storage. So when we store data, we want that data to be long-term in a horizontally scalable storage, and that that's flexible. In the way we do is flexible, as we'll see a few slides downstream. And also the aspect of being containerized and provides Kubernetes support. So we provide a bunch of operators, Helm charts, everything you need to do to run effectively on Kubernetes. So now let's talk about a few of the Pravega fundamentals so that we can understand some of the comparisons that I'm going to talk about later on. One core principle of Pravega is the one of a stream segment. Very simple. It's an append-only sequence of bytes. And those append-only sequence of bytes is the foundation for a lot of our main features. And we'll see why. So one thing that it does for us is enabling parallelism for a given stream. So I can have 3 segments in parallel. I can have the data source producing data to all 3 of them. And to do that, so the application, if the application cares about order for some specific things, for example, all events from a particular client, all events from a particular sensor, all events from a particular server, then we give the option of associating routing keys to that. And so with routing keys, we guarantee that they will be delivered downstream to the application reading a Pravega stream in the same order. And so this is one use of segments to give us parallelism, but that parallelism is not necessarily static. We provide the ability of scaling a stream. So when you're scaling a stream, and this can happen automatically, so Pravega is able to auto-scale a stream. So you can have a stream that starts with 2 segments. Later on, as the load increases, we can scale up that stream and go from, say, 2 segments to 4 segments. And later, if the traffic is such that the 2 top segments, S2 and S3, cool down, I can transition to a 3rd state, which is only 3 segments. So merging 2 segments and having 3 now instead of 4. So we provide this ability of scaling a stream up and down according to workload variations. Another thing that we can do with segments, because again we split them into this individual sequences. We can seal them and transition to different number of segments at a time. There are more things we can do with it. So we implement transactions using segments in the following way. For a given stream, we have the main stream segments at a time. We start a transaction. So application says begin transaction. We'll go and create temporary transaction segments. So as the application appends to the stream in the context of the transaction, they will go into those temporary transaction segments using routing keys as they are doing even without transactions. Now, when the application is ready, if the application commits, then we merge those segments to the main stream segments. And at that point, we make the data available for reading in that stream. If the application, instead of committing, it aborts, then we simply drop those segments. There was never a sign of that data again. So this flexibility in manipulating segments that we have in Pravega allows us to implement features like transactions and the other ones I have mentioned in this one. But there is more. So we provide revision streams where you can conditionally append to a segment. We use it internally to store data such as time information for watermarking. So all those are features that we also have. Let me now talk a bit about the main components and focus on event streams. We also have other APIs like for byte streams, but I'm not going to focus on or talk about those in this presentation. But those are also part of the API and interesting to have a look at. So when ingesting events into a Pravega stream, an application uses an event writer and appends to the stream. Internally, we track we check the writer position to avoid losing events or duplicating events. So in the case that the writer disconnects and connects back, we need to know where to resume from. So we track the position to be able to avoid, to guarantee exactly one semantics. On the read side, we have event readers, reading and processing those events. We group event readers into what we call reader groups. The purpose of reader groups is to be able to split the segment load across the members of the group and to balance that load over time. The group is not static. It's not that you create it once and never changes. We do provide a bit of growing and shrinking that group. Now, all this works even in the presence of stream scaling. So I talked about stream scaling before. So if the set of segments change over time, the reader group will adapt to that. Will distribute the load accordingly so that the readers can process that new set of segments. The service is implemented with two main components: the controller and the segment store. So the controller will do things for you like creating a stream, deleting a stream, taking care of, say, retention if you have a retention policy associated, performing updates to watermarks. So all those are responsibility of a controller, and also dealing with transactions. The segment store is not responsible for the concept of a stream. So the segment store is responsible for segments, as the name says, and it implements the data path, both for appending and for reading. There are two important abstractions that the segment store exposes. One is stream segments that we have talked about before, and there's an addition one which is very important, which is the one of table segments. So table segments expose a key value API, and we use that internally primarily for storing stream metadata. We wanted stream metadata to be scalable in Pravega, so that we are not limited by say the memory of the server. So we wanted to make it scalable, and so we implemented those table segments and we store stream metadata there. We also use that for key value tables, which I mentioned before, but I won't be talking much about this. We might have a breakout session that will be covered in more detail. Now, the segment store uses tiered storage, and there are two main components that we care about. One is the durable log. The durable log is there to guarantee precisely that durability. So when a new append comes in, we won't return to the application saying that the data is there before we persist it to the durable log. Durable log today is implemented with a project in Apache called Apache Bookkeeper. Asynchronously, we write that data to long-term storage. So long-term storage is flexible. So we allow you to use either a file system or an object store to store that data. So we have different bindings that we provide, and we plan to write more. And you can even write one yourself if you're interested, if you have the need to. But in principle, we assume that that's horizontally scalable storage, and we can. There is in principle no architectural limitation for the amount of data you can store over there. And again, that's our primary storage. All that eventually will make to long-term storage. Okay, so that's what I wanted to cover about fundamentals of Pravega, components, and some key concepts. Let me now talk about how Pravega compares to other systems out there, and talk a bit about some performance evaluation we have performed. So two systems that people often ask about when trying to compare Pravega with existing options. They are Apache Pulsar and Apache Kafka. So both systems share a log, and they recently have started talking about tiered storage as well, like Pravega. But there is a very fundamental difference across all three systems in the way they handle storage. In Pravega, as I mentioned, long-term storage is the primary storage of Pravega. We have a durable log that we append to guarantee durability, and we use in the case of recovery. But we, for example, never serve reads from that durable log. Again, it's there for recovery purposes. So main storage is long-term storage. For Apache Pulsar, the primary storage is the log. So when you're serving consume requests, you are reading from the cache or reading from the log. You can optionally offload some data to tiered storage. So recently they introduced a feature called tiered storage, in which you can send some of your code data to the particular storage. But again, it's optional and it's not even considered that their primary storage. For Kafka, the log is not external to the broker, right? So the broker and the log are coupled. So the log is implemented through broker storage. And even though Kafka talks about tiered storage, they have a proposal for implementing it. It is present in a company product. So Confluent is a company backing Kafka, and they have a platform that they offer. They have that feature implemented, but in Apache Kafka, in open source, that feature is not already is not available yet. So if we look at this again, they look similar because all of them talk about logs, and all of them, at least today, they talk about tiered storage, but conceptually, they look at those dependencies in a very different way. Another important difference is how we perform batching. In Pravega, one of the key things we observed is that in a lot of use cases we care about, you can have clients producing a lot of clients producing small events. If you think of sensors, for example, the samples that they're producing might not be very large. They will typically be very small, and they might not be producing enough of them to form effective batches, or large enough batches that will be effective when performing I/O. And so what we did is we opportunistically batch the data coming from a single client, but we also perform a second level of aggregation, and we take the data from multiple clients and aggregate that into a larger batch and perform a more efficient I/O. So in the case of Pulsar and Kafka, that kind of batching happens only at the clients. Of course, in Kafka, if you're using their default configuration, then you do have some opportunistic batching happen at the operating system level, at the page cache level. But that has another implication which has to do with durability. So as we'll see, this has an impact. So this design choice actually has a pretty significant impact to performance when we look at number of concurrent segments, and we'll see this a few slides down. Now, those are two important aspects related to architecture. So about features, two features that we care about, and I discussed a few slides back: stream scaling and transactions. So stream scaling is not available in Pulsar or Kafka. So Kafka and Pulsar do provide you the possibility of adding partitions, but it cannot remove partitions. And there is no guarantee guarantee of order as we have in Pravega for keys on a per key basis, even in the presence of scaling. For Pulsar, there is an issue created back in 2018, but last time I checked, there was no activity around it. For transactions, both Kafka and Pulsar have that implemented. Kafka has it implemented as of version 0.11. Pulsar has recently released it in 2.7. Both of them implement it in a way that they write the data directly to topic partitions, which is very different from the way that I showed you before. So we create transaction segments, and we populate those transaction segments. In the case of commit, we merge those transaction segments. So that's, again, different from the way that a Kafka and Pulsar are doing, which is to write directly to the partitions. So if you abort, for instance, then you're going to be leaving that garbage in those topic partitions. So that's one important difference between across these three systems. Okay, performance. So this is a performance evaluation. Actually, there are two steps to it that we have conducted in the past year or so. I strongly encourage, if you're interested, to go and check our blog posts. They have way more detail than I'll cover here. And they'll have more graphs, more detail on the setup and everything we have done. So again, strongly encourage people to go check it out. The first data I want to show is about the performance of Pravega alone, right? So throughput and latency. We have conducted these experiments on AWS using an open benchmark called Open Messaging. This is all of it. So the benchmark itself is available. So the data on how we deployed it is described on the post. This is all done in a way that if you want to, you can reproduce yourself. So this particular graph I'm showing is we generated it with 08, with version 08. We are now at 09. And the result I'm showing here is let me go through the graph. So what we have is throughput in events per second on the x-axis and write latency on the y-axis. Note that we are representing this in log scale. And for all data points that I'm showing, note that we are achieving single-digit millisecond latency, right? So when using one segment or when using multiple segments. One key thing to extract is, if we look at the point furthest to the right, we are able to achieve over 1 million events per second, events of 100 bytes, about 100 bytes in size, and single-digit latency. So this is excellent performance for that we are demonstrating here for Pravega. The next result I want to talk about relates to durability. Remember that I mentioned that Pravega is durable. We do not acknowledge an append until we have persisted that to the durable log. Kafka, for instance, does not make the same choice. By default, they replicate. You have the choice of when you want to get an acknowledgement, but assuming the strongest option they provide, you guarantee replication, but not necessarily that data is on disk. And so we tried two configurations here. One, the default, which is the solid black line, and the dashed line, which shows a configuration in which we force Kafka to flush on every message. So we can see that when we compare to Pravega, Pravega, which is guaranteeing durability, is guaranteeing a strong form of durability, the performance is comparable. There are points which are better, there are others that are worse, but the performance is very, very comparable. Now, for the one that we flush for every message, we force Kafka to flush for every message, the performance is considerably worse. So this is one of the key points that we extract from these graphs, right? So if we try to guarantee a strong form of durability with Kafka, then you get a much lower performance. While with the defaults, you end up getting this pretty much the same that you get with Pravega. Again, in some cases, Pravega is doing better. On the left-hand side, we see that furthest to the right, Pravega's performance is better. But in general, we get similar performance for a stronger guarantee of durability. This other result, so now this one was done with 09 and not with 08, but this is very interesting. So what we are doing here is we are imposing a constant traffic of 250 megabytes per second, okay, to all three systems, Pravega, Pulsar, and Kafka. So the right-hand side is about, so the left-hand side is about Kafka, the right-hand side is about Pulsar, both of them comparing with Pravega. we can see that Pravega, as we increase the number of segments in a stream, Pravega is able to sustain the traffic, right? So it's a flat line, it's able to sustain the traffic. So Kafka, for all configurations we tried, no matter whether you're flushing or not flushing out the number of producers you're using, eventually the performance drops. So when you get up to 5,000 segments, all those curves for Kafka have dropped at some point. For Pulsar, for the configuration we have chosen, we actually couldn't make it work well. So it crashed most of the time. So we did a configuration which was more friendly to Pulsar, which are the yellow lines. And then we were able to generate some data points. But even then, there were cases in which it crashed. So the two important takeaways here. One is Kafka is not able to sustain the target throughput as the number of partitions grows. And for Pulsar, we got lots of crashes, and it didn't perform that well with a large number of partitions. The last experiment I want to talk about is related to catching up with data in a stream, or if you want to see it that way, about historical data. Remember that in the beginning of the presentation, I talked about the need of keeping historical data of a stream so that it can perform analysis, it can perform all the tasks which are not just dealing with the tail of the stream. So in this experiment, what we are doing is we are starting a writer, letting it accumulate in a stream data up to 100 gigabytes, and then releasing the readers and seeing if the readers are able to catch up with the backlog of data, catch up with the writer. So when they catch up with the writer, then the experiment ends. And so what we see is, if you look at Pravega, the blue solid line, it starts flat at 0 because the readers they don't start until we have accumulated 100 gigs. Now, when we release the readers, there is a spike that can go up, goes up to 700 megabytes per second. And the readers fairly quickly catch up with the backlog of data. Experiment ends. We tried the same experiment for Pulsar. Remember that for Kafka we couldn't do it because it's only available in a paid product. It's not available in Apache Kafka. So when we tried with Pulsar, in the experiment we ran, Pulsar was not able to catch up. The readers were not able to catch up independent of the configurations that we have tried. And so this is what the red lines are showing. So the writer, the Pulsar producer keeps producing, the readers are not able to catch up, the experiment never ends. So this is another example in which we have shown that Pravega was superior in the performance that it provides. So that's it for evaluation and experiments. I want now to talk a bit about open source. So Shrikant touched upon the topic of open source, which is very dear to us. And I want to say a few words to reinforce that message. So all of our work is open source. So what you see on GitHub is what we do on a daily basis, the merges, the features. So that's the work we are doing for Pravega. No private branches, no private features. And we do not intend to change it. Our license is Apache License v2. It's a permissive license. There has been quite a bit of concern in the open source community recently with some notorious open source projects changing license. We don't really have an incentive to do it. We are not a company with a single open source product, right? So we have no reason to make such a move compared to other companies that are entirely focused on a single open source product. One of the key goals that we have for Pravega, and this has been a goal from the beginning, is to make it a community-driven project. And as part of that, we have recently proposed, and we have been accepted as a sandboxing project in the Cloud Native Computing Foundation. So Pravega is now part of a vendor-neutral foundation, which is the Linux Foundation, under the Linux Foundation, the Cloud Native Computing Foundation. As part of that, again, we are very interested in growing our community. So attracting more developers, companies, interested partners that want to help us to make this a healthy and thriving community. So with that, I just want to say a few last words about the path forward for Pravega. So Pravega is about streaming data, as we have discussed. I focus a lot on the aspect of the storage engine, Pravega being a storage engine. But today, if you go to the Pravega org on GitHub, you will see that Pravega is beyond just a storage engine that we started. So there is an ecosystem of connectors and tools and many other things that make Pravega more than just that storage engine. So growing that ecosystem of connectors, plugins, tools, etc., is definitely also part of our goals. Now, as part of those of building connectors and building support for other things so that we can build data pipelines, I want to mention that even though I talked and focused quite a bit on data streams, we in general want to support both the structured and unstructured data. You can count semi-structured data as part of that. So we want to expand our scope to always continue to increase the set of use cases that we can cover, both for structured and unstructured data. Edge is also very important to our development. So focusing on edge capabilities is part of what we're considering doing in our roadmap. As for community growth, I want to mention that we have monthly community meetings. So if after this hackathon you believe that Pravega, that's not the end for you with respect to Pravega, please join, participate, talk to us, contribute to all that. So those monthly community meetings are very interesting to engage with the other developers, engage with the community. Working with external contributors, we want to keep doing this and doing more of that. So if you're interested in contributing, come and talk to us on Slack, via the community meetings, all that. If you are part of a company who is interested in using Pravega or investing in Pravega, that's also a conversation that we can have. That's part of what we want to do as part of growing a community. Right? So have more partners involved in the development of the projects and the community. And finally, a very specific goal related to CNCF is the development of the project towards graduation. We have the goal of having Pravega eventually being a graduated project in CNCF. So for this hackathon, just want to say that, be creative, don't be shy, really push the boundaries of Pravega, show us, the things that we could be doing differently or better or whatever else that comes to mind. It's 2-3 days to just write code like there is no tomorrow and simply kick ass. All right. And last thing, there are 2 breakout sessions that I really encourage everyone to attend from Tom and Andre. They're going to cover they're going to go deeper into a lot of the aspects that I just touched upon here. So make sure to not miss those breakout sessions. Some references, personal references, contacts, and some websites that might be relevant for all the stuff that I have covered in the presentation. So thank you.
So I just want to add one line. I just want to have a closing comment on the spirit of Pravega, right? Some people have asked me why we have chosen this logo. So I just want to explain quickly on that. One is that we want to create freedom from the myriad number of open source licenses which are restricting the communities from growth. Freedom from looking at messaging systems as a temporary buffers rather than things that you can do both for real-time and processing. Freedom from treating eventing systems as places where you store only small events or files and then you have reference to some of the storage system. Freedom from storing as long as you want, and process them as many times as you want. And finally, the speed. As you've shown in the blog, the speed at which Pravega works is much better than Kafka and Pulsar, in spite of having guaranteed durability. And that's what the bird signifies here. Just wanted to complete the spirit of Pravega conversation before we move on. Thanks.
Thank you so much, Srikanth, for adding that and that insight. And Flavio, thank you so much for giving us the detailed overview and the flavors of Pravega. Before we move on to the next speaker, I would just like to welcome all the participants who have joined us a little later. Welcome to the opening ceremony of Unbounded by Dell Technologies. We have a Q&A chat box, which is there. So if you have any questions in the mid, we would definitely have a Q&A session. You can just post your questions in there and we'll take it up post the presentation. All right, so moving on, let me just share my screen. And if anyone can, if you can confirm, if you're able to view my screen.
Yes.
Thank you so much. Thanks a lot. So our next speaker is Mr. Andre. He's going to talk about Atos and their work with Pravega. So welcome, and leaving the platform open to you.
Thank you, Esther. Do you want me to share my screen?
Absolutely not. I'm doing that. You can just.
Okay. So the reason why we've been working with Dell for about a year and a half on Pravega and also on the streaming data platform, which includes Pravega as well, is because we believe there is a lot of added value into the product. Obviously, having a stream of data that we can rely on that transmit one and only one copy of the data, as Flavio explained to you with the story about the pizza, was very valuable to us. So we've incorporated Pravega and streaming data platform, as you can see in the middle of this slide, into our outcomes as a service offering. And the reason, one of the reasons why this hackathon is called Unbounded is because if you look at the edge, this is the fourth generation of compute, which is the first one to be unbounded, meaning outside the data center. This is the first time in the IT history where the compute and the added value of the compute will not reside in a data center, will be at the edge or at the far edge, and be able to compute data, run analytics, create a stream of data that's reliable and that is able for us and for anyone working with data to add value and create an outcome. And that's why we have labeled that offering outcomes as a service, because we are using this stream of data to create something valuable. So if you go to next slide, I just wanted to share with you a couple things and a couple examples. I've seen a question where we would like some use cases in order to get creative. So let's see a SLA as a service, for example. What if we take insights from robots and data from robots, streaming data from robots, from sensors, from their position, from their health, and make sure that they meet their SLA. So if you look at, for example, a car manufacturing, in order to create a car and specifically paint it, you need to involve about 12 steps, 84 robots, and the process takes about 15 hours, 24 hours a day, and some factories go up to 800,000 cars a year. So if there is a miss somewhere, and you can stay on that one for now. If there is a miss somewhere, that means that the SLA of producing cars will not be met. So what if we are able to, from far edge devices to cloud, we are able to ingest the data through Pravega, create a stream of data from all these 80-something robots to make sure that the paint is the right paint that's coming in, the right flow, the right position of the robot, the right quantity of paint. And when you look at all these cars coming in as a stream of cars, literally, you need to make sure that this entire data chain is consistent, so that at the end of it, the car is painted the right way, so that it doesn't have to go back in the chain. 800,000 cars a year is a lot when it comes in out of a single factory. So creating the right analytics on that to ensure the quality of the car is a good thing to do with streaming analytics. If you go to the next one, what if instead of data from robots, we take data from video cameras, right? It's a data set like another one. Pravega is able to handle streams of bytes, as Flavio explained. So what about video cameras? And out of the same platform, same streaming capability, same analytics, we could have predictive safety as a service. I would have loved to show you a video, but I don't think it's gonna go well sharing here. But basically, think about video analytics where you can detect a fire, detect fumes, detect someone who is wearing a uniform, someone who is not wearing a uniform and should be, or someone who, this is common these days, someone who is wearing the right protective equipment. All this can be done through analytics of byte streams into the same platform. Let's go to the next one. What if we get analytics, data from pretty much everywhere? Just a couple of clicks. Let's say, I'm sure you have all heard about the PlayStation 5 rollout that was pretty chaotic, to be honest, because the warehouses were empty. So what if with same thing, the analytics platform, we get data from social media to understand where the buyers will be. We make sure trucks are available and drivers are available instead of being on vacation playing golf. We look at the weather data to make sure that we will have the right planes coming in to bring parts. And all that together, we'll be able to have warehouse full and being able to provide the right logistics, and that's smart logistics. So again, that's another use case where having a stream of data coming in, we are able to react a lot faster at the global scale in order to provide the right outcome. Next one is a bit more tricky, and I'm sure you all have experienced that, where it comes to user retention. I'm sure you have seen websites where you're about to leave a website and the website is telling you, hey, I see you have something in your cart and you haven't bought that. And I also saw that you looked at that laptop sleeve. So you've got a laptop in your cart, you've looked at the laptop sleeve, but the laptop sleeve is not in your cart. And I know that because I analyze a stream of data coming from your interaction on the website, how long you spent on which page, where your cursor was, and everything. Today, this is something that exists. And applying Pravega on top of that and being able to analyze the stream of data, you would be able to say, hey, what if I give you 5% discount so that you buy the laptop and the sleeve that you looked at and that's not in your cart? So again, just use cases that are available out there, and we've been working on some of them. And last one, which I really affectionate, because this is a project I've been directly involved on, predictive maintenance as a service. So what if you consider a ride, like a theme park ride, and Asta, if you don't mind clicking a couple times. The reason why you've got a line at the front of the ride is because the ride is down during open hours, and you've got some failures, and therefore the line continues growing, and you are waiting in line to get on the ride. You are not satisfied because you've paid a lot of money to get in the theme park, and you've got a long line because the ride is not reliable. So what if, with the right sensors, temperature, vibration, etc., that all come as a stream of bytes through the same platform, what if we are able to make the ride work and shorten the line? This is something that is very valuable outcome for customers. And today, think about a ride having about 10,000 sensors. So remember the performance that Flavio explained, 10,000 sensors sending their data every 2 milliseconds. That's something Pravega is very valuable for. So I really wanted to go through these few use cases to give you ideas. We've been working on that for a few months and almost a few years now, jointly with Dell Technology. So I just wanted to share that with you. And back to you, Asta.
Thank you so much. That was really, really insightful. Okay, moving on, I think we will just go to our next speaker, Mr. Ashish. He's going to talk about the engineering team of Pravega. So over to you, Ashish.
Thank you, Asta. So my name is Ashish Patwara. I lead the Pravega engineering team. I must say that the Pravega team is of talented engineers that I'm proud about. Though the Pravega engineering team at Dell is part of the larger team, but it embraces an open source community-driven ecosystem, so much so that many other internal Pravega teams, even within Dell, also contributes to the open source Pravega. So it's like we are embracing this open source culture within and even within the outside the community as well. So in a way, the Pravega enjoys, best of both actually, right? Support from Dell while encouraging open source community involvement. So we religiously follow the open source procedures all the way from requirements to release. Let's talk to the next slide. Let's talk about the high level Pravega development process, right? So we start with the ideation phase, right? The ideas can come from community members, from engineers, from product managers. Go back to the previous slide. Asta, can you go back to the previous slide? Yeah. So the ideas can come from anywhere, like customers, partners, community members, engineers, right? Even product managers, right? So once the ideas come in, we look at the ideas. The next step is to understand it in a much better fashion, and then identify if there is clearly a merit in proceeding with the next step, which is developing a proposal. We call it as a PDP, the Pravega design proposals. So now what happens is a responsible engineer is assigned to that. The engineers basically talks to the stakeholders, understand the ideas in a much more detailed fashion, does POC if needed, right? And take it and basically have this PDP ready for the next step, which is the design review. And in the design review phase, we review it with the stakeholders. We also identify if there are any corner cases that we need to be addressing, right? And then at the end of it, we get an approval from the community members or the stakeholders, and after that we assign a developer or a set of developers, right, who can take it to the next phase, which is like implement the idea now. As part of the implementation, we break down the task into multiple subtasks, right? And basically in most of the cases, the feature development happens part of the separate branch. That basically we do a lot of testing in that branch, make sure that the feature is ready before we merge it into the main branch. We developers write their unit tests and integration tests. And one of the other thing that we basically strictly follow is the test coverage. We ensure that every check-in that we do in the main line follows a test coverage pattern. And right now that is set to 85%. That means we are not allowed to merge our code in the master branch if unless it is maintaining 85% code coverage. And as part of this implementation process, we update documentation as necessary. Right. Once we satisfy with the feature, we've gone through the code reviews, we have done all the unit testing and integration testing, then we are allowed to merge it into the master, right? And that's our next step. Even though while the system, we perform system test, but it is not a gate. It happens on a real cluster, but it is not blocking the code merge. We do find issues with the system test. Whenever there are issues, we basically look at immediately and we try to rectify those issues as soon as possible. So this is how the typical Pravega development process happens. Now let's talk about three fundamental principles that, next slide. Three fundamental principles that Pravega engineering team follows, right? The transparency. We understand that that basically, our users and contributors are from different geography, different time zones, different culture. We try to be as transparent and as communicative as possible. We follow most of the open source tools and communication methodologies. We do have our own Slack, right? We have our guidelines such as design templates, code reviews, contributions, guidelines, and README files are all in public domain. They are available through our GitHub. And as I mentioned, we communicate through public Slack channels. Anyone can join those Slack channels. Anyone can discuss their ideas, right? And we community members respond to those ideas, respond to those comments as soon as possible. The next step is the participation. There are two key things that we try to do, to encourage participation. One is minimize friction, right? We encourage higher participation by minimizing the friction. The friction basically is nothing but, the time you have your idea to time to complete that idea. We try to we try to set up calls, and we try to communicate as much as possible to make sure that that you get your answers. And the second thing is the automation. We try to automation our setups, builds, tests, etc. So that way, we when we review the code, we focus on the actual code part, not just okay, have we tested it? Because that is by default expected from community members, and for that we already have an automated infrastructure to accomplish that. And the third thing is, of course, collaboration, both internally within the Dell and externally. We encourage collaboration. We have, in fact, we have now monthly community meets where community members participates in those community meetups. So we believe that the transparency enables participation, which enables collaboration. That's a key principle that we follow for Pravega. And I'll just touch upon next slide. I'll just touch upon a little bit about why, as Srikanth and Flavio mentioned, that we open source Pravega and it's Apache 2.0. Anyone can contribute to it, and then there is no private copy of it. Everything is in open source, right? So why Pravega Engineering embraces open source, right? So for us, open source is not just a code, but it is a community, and community is bigger than just us. It allows us to create a partnership that is beyond a corporate boundary, right? That's the fundamental principle that we have. The second thing is in the ownership. It boosts engineer morals, as well as they give them the ownership, right? Engineers feel proud of sharing their work with friends and families, right? And then basically they feel that they own certain component in public domain. And the third thing is that it helps writing better quality code. Engineers pay enough attention, when the code is in public, right? It is similar to you do most of the key cleaning when just before guest arrives. But in case of open source, right, the community is always there. The public is always there 24/7. So you basically and engineers strive to do a better quality job, right, when the code is in public. And the fourth is that it creates a thought leadership, which drives innovation. And the last but not least is basically it helps attract top talent. Because we by sharing and collaborating, right, we are growing the community together, right? The engineers are working with each other and improving it. That's all about the Pravega development process, as well as Pravega engineering team. I must say that it's a top talented engineers that we have that kind of contributing to the Pravega. Thank you.
Thank you so much, Ashish, for that insightful session. And thank you so much, all the keynote speakers, for your insights over Pravega. I'm sure our participants would have loved the session. And in case any of the participants has missed it out, we definitely have that recorded in Zoom. So we would send the links to you shortly. All right, quickly moving on to the operational aspect of it. Let me quickly start off with the hackathon rules for you. So the rules, obviously, they are mentioned on the website, but all talented developers and designers here like you who are above 18 and are the residents of United States, Asia Pacific, or Japan are invited to attend. We would want you to officially begin the projects immediately after the coding begins, which is immediately after the opening ceremony that we are having right now. And the winning team is obviously subjected to a code review that could be immediately, that could be during the event or immediately before winning. This is really important, and I would like your focus here, because this is what we're going to have in the next 3 days, and I wouldn't want any of you to miss out the action that we are having. So this is the opening ceremony, and if you have missed it out, we have a Zoom YouTube recording for it, and we'll share the links. Coming up immediately post the opening ceremony is the breakout session, and this is very important. We have our mentor, Mr. Andre. He's going to speak about the key features of Pravega. So I would recommend, like Flavio said, to not miss it out. It's going to be really interesting, and you can have a Q&A session after that. As I mentioned, immediately after this, you are free to code, so the coding begins. We then have the mentor office hours now between 11:30 to 1 p.m. These timings are all in CST, so you can kind of convert it. But we have also sent you calendar invites, so do not worry. You can just go to the calendar and see the invite and click on it. So the mentor office hours, we will have some of the mentors joining us, and you can post any query you have, any questions you have on that. And last but not the least, to end the day, we have happy hours. So we have some fun games for you, and we have exciting prizes across, and we have speed networking. So you get to talk about topic, and we get to hear about it, and you connect with your friends. So do not miss that happy hour session. Moving on, what we have in store for you tomorrow, we again have a 1-hour mentor session. So for all of you who missed out the mentor sessions today, we have mentors joining in for you between 9 to 10 a.m. tomorrow. This is again CST. Then we have the second breakout session, and we have our mentor, Mr. Tom. He's going to speak about event-driven architectures in Pravega. So again, highly, highly recommended, for you to join that session. It's going to give you a lot of insight about Pravega, and we would have, though the links are already there in the invites and Telegram and Slack, but we would definitely send it across to you again. And we finally have the pitch workshop to close the event. The idea behind the pitch workshop is that, while you would be gearing up for the submissions, we would just, the Angel Hack team would want to help you out, try to sharpen the skills, etc. So do join in the pitch workshop. Day three, we have the last technical help session for you. So the Dell team is going to be there on the call. They're going to help you out with any technical queries you have between 9 to 10 a.m. CST. We have the submission deadline, and you please be very, very mindful of that. We would give you alerts. We would also be sending out mails for the countdown of the submission deadline, so that you do not miss, the submission deadline. We then have our judges deliberate the projects that you have submitted between on the 16th, and finally we have the closing ceremony. And we would definitely want you to tune into the closing ceremony, which is happening between 9 to 9:30. 17th May. This is again CST. Where we would announce the winners, and obviously we would have the award ceremony. So that's the hackathon schedule for you. Moving on, we have already introduced the judges. We would like to introduce the mentors who would be helping you out throughout the event. We have Mr. Tom, and he's also one of our breakout session speakers. He's the distinguished engineer at Dell Technologies. We have Mr. Andre. He's the distinguished member of technical staff at Dell Technologies, and he's going to take the next breakout session, so do join in for that. We have Mr. Raul. He's the software principal engineer at Dell Technologies. We then have Mr. Sachin Joshi. He's the software senior principal engineer at Dell Technologies. Some more mentors for you. We have Mr. Igor. He's the senior manager, software engineering at Dell Technologies. We have Mr. Shivesh. He's a software engineer at Dell Technologies. We have Ms. Prajakta. She's the software principal engineer at Dell Technologies. And finally, we have Mr. Sandeep. He's the software senior principal engineer at Dell Technologies. So all of these mentors would be there available for you on Slack in the mentors channel. So any query, any questions, you can just post to them. And we also have the mentor session for you. All right, moving on, the team who actually created this hackathon and was working behind the scenes for it. We have the Dell organizing team, Miss Amy. She's a senior advisor product management manager at Dell Technologies. And we have Mr. Derek Moore. He's the software senior principal engineer and Pravega.io community manager at Dell Technologies. So thank you, Amy and Derek, for helping us curate this. And with that, I would hand it over to Amy to take you through the prizes and the judging criteria. Over to you, Amy.
Thanks, Asha. So the first thing that I wanted to go over is the challenge. So of course, Flavio and everyone else talked about Pravega and what Pravega is, and the open source nature of it. So what we want you to do throughout the hackathon is take Pravega and find a creative idea to use Pravega. So Pravega, of course, utilizes streams of data. There are a lot of examples of public streams of data. You may also have access to private streams of data. If you have an idea and you think that there may be a way for us to help you get that stream of data, please reach out. We'll do everything we can to try to help you with that. But the idea is to just find that stream of data and find a creative way to harness it, to get some business insights out of it. That idea is a large portion of the project, but of course, we also want you to do some coding to show that it is an executable idea that may be by a person, an organization, a geographic location like a city or a state or a country, whatever it may be. We want to see that it's feasible. We want to see that it's creative. We want to see that it's going to fix a problem that people have. And we want to see the code behind it, of course. So all in all, the submission will include a document, a PDF, very short, 1 to 3 pages. We just want to know those 4 key points. What's the idea? What's the data source? How is it fixing something? How you got to that idea. And then a video kind of rehashing that document so that the judges, have 2 different ways to kind of feel out what exactly the project is all about. And then, of course, the GitHub project link will help our judges to take a look at that code and see what it's all about. So the winner will get a grand prize of $5,000. So if that's a team of 1, that one person will get $5,000. If it's a team of 5, you will collectively get that $5,000. And then the runner-up team, each team member will get an Oculus 2 VR headset. And the first 25 submissions, regardless of who wins, if you are one of the first 25 submissions, you'll receive a Dell Technologies and Pravega swag box that's valued at more than $100. There's some really great stuff in there, so try to get one of those spots. And then the judging criteria. So I did touch on this earlier. What the judges will be looking for is a mix of 4 different things equally. The first is the challenge. So does it address a need or a challenge in today's world? What is it helping to solve? Kind of why did you think of it? Why should people care? And then creativity. So this can go in a lot of different directions. The idea is how creative are you in terms of the general idea, in terms of using a data stream, in terms of utilizing the code and that data stream. And then the impact. How is this going to have a real and valuable impact in the world? And the feasibility. So again, that could be for a person, a large organization, a startup, a geographic area, whoever. It doesn't have to be for someone specific, but is it something that's actually feasible?
Thanks, Amy. Thanks for that. So coming quickly to the winner announcement, how are we going to do the winner announcement? So first of all, again, touching upon the submission deadline. The submission deadline is on the 16th of May, 12 p.m. CST. We will be sending reminders, but do not miss out the submission deadline because that's what you're, hacking for. All the projects are going to be then judged by our esteemed panel of judges on the 16th of May, and we finally have the winners announced for you in the closing ceremony live on between 9 to 9:30 a.m. CST. So don't miss that out. Immediately following that, we will have the winners of the swag boxes announced on Slack. So that is how we would be announcing the winners. Our support, and this is really critical. While most of you have joined Slack, I would just like to take this moment to let all of those participants who have still not joined Slack and our Telegram group to definitely do that, because you have a lot of details coming out there and the announcements, plus our support. So if you need a team member, we have the team building roster. Just put in your details and we will help you find your team. We have announcements, we have need help. We also have a mentor special channel, and we have on Slack, so you can post your queries there, but we are having dedicated mentor office hours as well. And finally, we have the pitch workshop. So a lot in store for you. And if you're looking for any other support, do ping us, any of the organizing team members, and we'll be there. Now, this is very important, and have a look at it. How do you submit? So basically, register your project at virtual.hackathon.io, and what you will need to do in terms of submitting that. So basically, we would require you to have one PDF that describes your idea. Try to put it, and the idea should be in detail, but try to minimize it to 1 to 2 pages. We obviously would want one link to your GitHub project. And finally, we would want one video, MP4, and less than 5 minutes, that describes your idea and the challenges that addressable, and the data source that is used. If you have any issues, or if you have any questions around this, definitely join our pitch workshop, because that is where we are going to give you details on how you can improvise on this. Hackathon facts, I think most of you know it, but still, for all those of you who have joined anew, I mentioned who can participate, how can you get help, but just let me touch quickly upon the fresh code rules. So basically, all the code developed as part of the Dell technologies must be fresh. So this is really important, that while the developers like you can do the wireframe designs, etc., but actual coding should begin by, as the coding begins, which is happening exactly post the opening ceremony. So you can start hacking or coding post we close the opening ceremony. Okay, we actually wanted to have a team formation session for you. We already had that, one of the team formation session in the pre-hackathon webinar. But the idea is, if you're still looking for a team, do not hesitate. Just fill in our roster that is going on in the Need to team, and our community manager would help you out find a team. You can also just quickly scan the barcode that is there, or go to the bit.ly link and give your details, and we'll be happy to help you. So with that, we will open the floor to Q&A, and I would like to invite my colleagues, Trisha, as well as Harish, to help us out in this. And I think all of you have posted your questions. If you still haven't, just try posting it in the Q&A box, and our team will be answering that. But for the advantage of everyone, we will read out the questions, and so that all of us as a team can find answers to that. So with that, I'll just stop sharing my screen and quickly go to the Q&A. All right, so we have some questions which are already answered, but we would still read it out, and if our esteemed judges or mentors could give us a quick overview on that. So one of the attendees asked, since Pravega supports streaming data, can I use it to analyze tweets from Twitter stream? And Flavio says, yes, definitely. I think that's a clear answer, so we don't need to go in the details of it. Let's go to the second question. The attendee says, Flavio, thank you so much for the detailed presentation. This absolutely helps us getting started and understanding Pravega better. Would you, where do we find some use cases to get some ideas on what to build? So I think Flavio has already mentioned that, but do you want to take up that question, Flavio, for the larger audience?
I can think of a, so let me turn my video on. So I can think of a single place I can point for as a source of references. So that's why I suggested to go on Slack and ask the question, so that we can post some references there. But of course, we can talk about examples here if you want. I think Shrikant.
Yeah, I think Pravega.io, if you go to the website, it gives some indication of what kind of things you can build on it. And also, that's why we had Arnaud today, because they have used the system to build practical applications. That's why we had his presentation to talk about, so that it sparks some ideas in your mind. So that's the reason why he presented today. But of course, Slack is a good place also.
Sure.
Yeah.
Thanks, Shrikant. Thanks, Flavio, on that. Okay, the other.
So someone else who was So there is someone who was, I think, trying to talk.
Hi, Shrikant.
Hi.
It's Tom.
Yeah.
Yeah,
Good.
I was just going to add, for anyone looking for ideas, go to the Slack and join the mentors channel. I just posted a large link with a lot of references that people can use for various ideas. And feel free to reach out over that channel. Any of the mentors would be happy to help.
Thanks for that, Tom. The other question, I think Ram is asking the question. He says, is there a YouTube channel where we can look at some use cases and tutorials to get started in Pravega? Well, Trisha has answered that for you and sent the links as well. So I hope, Ram, that answers your question. And also, I think Tom has sent you a link. So the next question is from Mr. Sayed. He asked, hi, will these slides be posted? Thanks. So Sayed, if you're asking about the slides that we were presenting as a part of the opening ceremony, you already have this opening ceremony recorded on YouTube, and we would be sharing the link. So you can just have a look at that from there. Okay.
Hey, just in the interest of time, can you just go through the open questions, because everything is visible for all the participants?
Sure, absolutely. Okay, from the open questions, I think Amit asked also a brief and critical SLA support parameter. Flavio, in case you're typing that, if you could answer it for the larger audience.
No, it's not that. So, okay, I actually wanted some clarification. What kind of SLA support parameters would Amit be interested in? The question is fairly open.
Mm-hmm. I agree. I would recommend, Amit, if you could post this question on our Slack channel. I think we would be able to give you a detailed answer over there. In the interest of time, I think let's take this question to Slack.
Yeah, Amit, when you say SLA, we are not providing this as a service somewhere, right? So the concept of SLA doesn't arise unless you provide a service. This is a product software that you can deploy anywhere in the cloud and elsewhere. When we provide it as a service, then we will talk about SLA. So right now, this is a complete scale-out product. There are no limitations. The only physical limitations of what you're deploying, where you're deploying, really come into picture, if you're meaning to ask about that. Yeah, go ahead, Asta. Next question.
Thanks for the clarity, Shrikant. Okay, the other question is from Brad, and Brad says, it sounded like Amy said 3 pages PDF. Okay, Brad, if you're talking about the submission, we suggest that you do 1 or 2 pages PDF, but if you're going in for 3, there is no harm. So, so no worries out there. I think there's another quick question. Is it necessary to always, okay. Yeah,
oh, sorry. Yeah, I just found one
Trish.
question from the chat earlier. So I think someone asked whether Pravega can be used as a Firebase. So I think I'll leave that to Flavio and Shrikant for you guys to answer.
As a what base?
I couldn't hear you, Trisha. The Pravega can be used as what?
Oh, as a Firebase.
Firebase? What do you mean by that? I don't know.
This question was from, let me see. It's from the chat. So it was asked earlier. And it's from,
can you type it here if you don't mind in Q&A?
Yeah, sure. Give me a sec. I'll type it on the chat itself if it helps. So this was the question asked. Can
if my guess is right, can Pravega be used as alternative to Firebase or as Firebase, or link Pravega and Firebase together? Firebase is the Google's product.
Yeah.
What kind of API does it provide, Firebase?
It's a key value storage database. So
it provides concurrent synchronization, and like the idea is that you have multiple clients. It's usually pitched at mobile devices, updating a common shared state. So I think I can speak to that. So Pravega doesn't have something that's like, it's not attempting to compete with Firebase, to be clear. We do have a mechanism to synchronize global state called State Synchronizer. I encourage you to look up the documentation on that. It's an interesting mechanism, but basically it allows you to have a chunk of memory that's in process on multiple hosts, and then use updates to the Pravega stream to coordinate changes to that. And by using Pravega's underlying consistency, you're able to have strongly consistent results across all of the hosts that are using it.
Also, I encourage everyone to attend Tom's presentation. He's going to cover State Synchronizer in detail, those of you who want to use it.
And if you don't want to wait till tomorrow, I will talk for a few minutes about it today as a quick intro, so you know what this is about. And Tom will talk about it in more detail tomorrow.
Thanks, Tom. Thanks, Andrew, for this. I think in the interest of time, and since we have the breakout session immediately coming up, so we would wrap this session. What we'll do is, if there are any unanswered questions, we will take the questions to Slack so that all of your queries are answered, and we will go to tag all the mentors so that we have the queries answered. Now, before we end the session, I would just like to say that for all of you who have not joined Slack and Telegram group, just do that immediately. You will have all the sessions and the invites and the announcements coming in there. And we have a breakout session immediately coming up post this from Andre. So do join in, for that. It's going to be really interesting. With that said, I would just like to thank all the participants who took time out to join in the opening ceremony. I hope you guys are staying safe, and it was really glad to host you. We are really glad to host you. If you have missed it out, if you have a recording on YouTube, we'll be sending out the links shortly. And also a big thanks to all our panelists who took time out today to join this session. So thanks a lot. We would be seeing you on the other side for the breakout session. Thank you.
Thanks, guys.
Thank you.